In systems of nonlinear equations, I'm dealing with equations that are not lines. At least one of them has to be something other than a line. But the idea is still the same. What I'm going to be looking for are a set of numbers that will be true for all of the equations in the system. And to go about finding that, I use the same methods as I would for linear systems. I can use substitution or elimination. And in general, I've found elimination to be more preferable. It's less algebra involved. So here I'm going to use elimination and go about solving this like a regular linear system of equations. So I can take the second equation and subtract it from the first one. That will eliminate the x variables. Just distributed the minus sign so I don't make any foolish mistakes. Here I get a y squared plus y. These y's do not add, so there are different powers. And now it is a regular quadratic equation. I get y is equal to minus 5. Now for a linear equation I would get one answer. I would get x is equal to 1 or z is equal to 3 or y is equal to 2. But here I have two numbers to back substitute. And that is because in nonlinear equations they're not straight lines and they will intersect often at more than one point. And if I look at these equations, I have a circle and I have a parabola. And these could intersect a few different ways. They could intersect not at all, like right now. They could intersect one time with one of the arms of the parabola touching the circle. It could intersect twice. It could intersect 3 times. The bottom could be touching and then the two arms could intersect. Or it could be a very narrow parabola and it could intersect 4 times. So there are going to be situations where we're going to have more than one solution. When in linear systems there are either, at least with 2 dimensions, there was one solution, infinite solutions, or no solutions. But with nonlinear systems there can be a lot of different things happening depending on what kind of equations are given. So here I'm going to back substitute y is equal to minus 5 first. I need to do both of them. And I'm going to put it into the second one because there's one less square. And it does not matter which equation it gets replaced back into. And it's important to note that. It does not matter if I did the first one or the second one, I would get the same answers. But I'm going to do the second one. So whenever I do have more than one equation, I should always pick the more simple one because I'll have less math to do and I'll get the same answers. So here this one is slightly more simple, smaller numbers, and only one number is being squared. So I'll substitute these in. X squared minus 5 is equal to 5. X squared plus 5 is equal to 5. X squared is equal to 0. X is equal to 0. So one of my points or solutions for this system of nonlinear equations is 0 minus 5. Now I may have more because I've yet to substitute back y is equal to 4. So I'll substitute it back into the same equation and I'll see what happens. is equal to plus or minus 3. So I'm going to get two solutions to the system of equations from this back substitution, because I will have minus 3, 4 and plus 3, 4. And now I've run out of things to back substitute. If I had a higher order equation, or if it intersected more times, then I may possibly have more things to back substitute. But I've run out, and this is what I'm left with. So the solution to this system of nonlinear equations, minus 3, 4, 0, minus 5, and 3, 4. And I've taken the liberty of graphing this all out beforehand to get a better idea of what is happening in this system of nonlinear equations. What I have found is the solution to the system of nonlinear equations. And again, what I mean by this solution is that these are the points that are true for both of these equations, and it's where they intersect. The only places they have in common are the places they intersect. And this is what they would look like graphed. Let me write x squared plus y squared is equal to 25 is a circle with a radius of 5. 1, 2, 3, 4, 5. So here's the radius of 5. And then x squared minus y is equal to 5 is the same as y is equal to x squared minus 5, which is a regular parabola shifted down 5 units. Here's where it would begin. I've shifted it down 5 units, and these are where they intersect. So that is where the solution to these systems are. And the other reason I have drawn this graph is because I want to quickly go over systems of nonlinear inequalities, because they work exactly the same as linear inequalities, where I'm shading a region for where there is a true statement, or where there's a true statement. So if I were to take the same equations and then change them to inequalities, and I'll say that it's less than or equal to 25. And may as well do less than as well. The way to solve for these is the same as for linear inequalities, where I'm looking for the set of points where this inequality is true. And the best way to do that is by graphing it and then testing a point such as 0, 0. So for this circle, either inside of the circle will be true or outside of the circle will be true. And to test which part of the graph is true, I pick a point. I'll pick 0, 0. 0 squared plus 0 squared is less than or equal to 25, which is true. So this entire region inside of the circle is true, also including the circle itself. And now for the system, I have to find out what mutual area of shaded region these both graphs have. Because again, a system of equations or inequalities is looking for the points where the statements are true for all of the equations. So now I have to find out what region of this parabola is shaded. Either the inside of the parabola will be shaded or the outside. And the best way, again, in this situation, and 0, 0 is the best choice. 0 squared minus 0 is less than or equal to 5. 0 is less than or equal to 5, and this is true. 0 is less than 5. So the inside of this parabola will be shaded. Now I did not shade it yet because I don't really want to make a big mess like I did last time. So I have the inside of this circle shaded and the inside of this parabola shaded. And the solution to the system of inequalities is the area that is shared by both. So that would be the inside of the circle and the inside of the parabola, which would cover this area. So that is the solution to the system of nonlinear inequalities. It works exactly the same as linear inequalities, no difference at all, just different shapes of graphs.